Hi friends, welcome back and welcome to my channel Techie Krish or GAG Agra. So today I am going to discuss the conditional statements as we have been discussing the same, and since I am going to use more in today's video, like I want to include the logical operators, I want to include operators chaining, I want to include identity comparisons. So how to apply and what are these statements, logical operators, operators chaining, and anti comparison. We discuss this in our video. So let's start. So a simple condition can be formed using relational operator. Sometimes a condition contains more than one comparison. When we have multiple comparisons, then we'll have to use the logical operators. For example, to check the marks are in the range of 28 to 32. In this case, we have to check as marks are greater than equals to 28 and marks are less than equals to 32. So this way we need an operator to combine these conditions, like greater than equals to 28 and less than equal to 32. So each relational operator forms a simple condition. If a condition contains more than one relational operator, then we can say that condition is a bit complex because you are going to combine multiple conditions in one statement. So such a complex condition is formed by using simple condition, using the logical operators. So a complex condition can also be formed by negating a simple condition. Sometimes we want to negate the condition, means complement the condition, means we have to use the not operator. So this not is also a logical operator. For forming complex conditions, we have to use logical operators with simple conditions. Different logical operators are here in Python. We can see. So here we can see the logical operators like not. What does not do? It negates a condition and returns true if the condition is false. Otherwise, it returns true. Return false. Because when the condition is false, then negate of false is true, and if the condition is true and negative of true is false. So not x greater than y. Why? Because if x is 5 and y is 2, so x greater than y means 5 is greater than 2. Yes, this is true. So when you say not of x greater than y, it will return false. Similarly, when we combine the conditions using AND, combines two conditions and returns true if all the conditions combined using AND are true. Otherwise, it returns false. So if x greater than 3, since x is 5 and y is 2, so if you check if x greater than 3 and y less than 2, so if you see x is not greater than 3 because x is 5 and y less than 2 is not less than 2, and that is why this statement will return false. Then we use OR. When we combine two conditions using the OR operators, then it returns true if at least one of the conditions is true. Otherwise, it will return false. For example, x greater than 3, so x is 5, so 5 is greater than 3, or y less than 2. So here x is greater than 3, and that is why this returns true. Now When multiple logical operators exist in an expression, their execution sequence is decided by their precedence order. Precedence order of logical operator is not is greater than and is greater than or. It means that not has the higher priority than and, which has the higher priority than or. Means not has the highest priority than and in in the end we'll use or, and that way not has the highest priority. This precedence order can be overridden by using parentheses. Let us understand this with the help of the few examples. In this example, we assume that x is 3, y is 4, and z is 6. Let's see. So the first example, x greater than y and y greater than z, or x less than z. So x greater than y, no, is false. Y greater than z, no, is false. Or x less than z, yes, this is true. Means and is false but or is true. So as far as precedence is concerned, and is evaluated first, so it will return false, and x false and false or true. As I said, x greater than y, false, y greater than z, false, but or operator, logical operator, gives the true result, and that is why this expression becomes false and false or false. So we'll evaluate false and false, so it will be false, so it will give you false or true, and finally it gives true. Now next example, not x greater than y or y less than z. So see, x greater than y, so x is 3 and y is 4, so x greater than y is false. So not of false, we'll evaluate not of false, and after or y less than z, so yes, y is less than z, so this will give you not false or true. So not false is true, and true or true will give you true. Next, x greater than y, no. Y less than z, yes. So false or true will give you true, and not of true should give you false. So not false or true, because x is not greater than y, so this gives false or true. Then not of this, negative of false or true will give you false. Not of true, this gives false. Now next example, not x less than y and y greater than z. So here we'll evaluate not first, then and. So x less than y, so x less than y, yes, this is true. So not of true is false, and y greater than z is also false. So let's see. So not true, because x less than y is true, and that is why not true will give you false, and y greater than z is also false, so it will give you false. And now evaluate the next statement, and this is x less than y and not y greater than z. So x less than y, yes, this is true. Y greater than z, no, it's not true. So x less than y is true, and not y greater than z, not false. So true and not false. So here not false is evaluated first. So true and true is the outcome of this statement, and finally it will give you the true output. Correct? So this way we can see these logical operators work, and the output this way come, and here we'll have to keep in mind the priority of every logical operator. So not is above and is above or. Now discussing operators chaining. So usually students use in maths like x greater than y and greater than z. So x greater sign then y greater than sign z. So usually students used to do this in the test paper or in their working. So it is allowed in Python. Means chaining of relational operators is allowed in Python. For example, x less than y less than equals to z. It means x less than y and y less than equals to z. It is allowed in Python. In general, if a, b, c are the expressions and op1, op2, op3 and opn are relational operators, then a op1b, op2c, op3d and so on, y operator n and z is equivalent to a op1 and b op2 and so on y up till y opn z. So we can apply the condition like x greater than y less than equals to z. It can be applied in Python. The operators is and is not are used to compare the object entities. Means x is y will be true if and only if x and y are the same objects. That is, they refer to the same memory location. Means if x should point to the memory location where y is pointing to. So and that is why they are the same objects. And when you compare the entities, then if these two variables are pointing to the same memory location, then in this case x is y becomes true. Correct? So the memory location is the location where the values of these variables are stored. Means they refer to the same memory location. Object entity is determined using the id function. So there is a id function in Python which gives the memory location when you use the variable along with the id function. Okay. Now suppose a is 10, b is 10.0. So if you compare a is b, not, because a is integer and b is 10.0, this is float, so they cannot occupy the same memory location, and that is why a is not b, and it will return false like this. Print a is equal to b. Yes, if you apply equal sign, in this case a and b are the same, but they are not pointing to the same memory location in the previous statement, and that is why a is not b. So this gives false. Otherwise a is equals to b. So see, if c is equal to 10, print a is c. Why? A is c returns true. Why? Because a is integer 10 and c is also pointing 10 in the memory, and that is why it gives true. If a is equal to c, this is also true because values are same. D is equal to b. So what is d? Because whatever value b holds, it moves to d. Means d and b are pointing to the same memory location 10.0. So D and B are pointing the same memory location where 10.0 is stored, and that is why D is B is correct, and it gives returns true. And of course D is equal to B because D is having 10.0 and B is also having 10.0, that is why equal. So in this case memory location is the same, so this it returns true. And when we compare A is B, A equals to B, this or D equals to B, this is also true because they are having the same values. So A is B implies that A is equal to B but not reverse, as as we have seen through this example. Is versus equal. Is operator checks whether two objects have the same identity, means the same memory location, whereas equal has nothing to do with the identity. It simply compare the values. It just checks whether two objects have the same values. So this is how we can consider operator chaining, identity comparison, and logical operators. So hope you understood the concept here. So we can apply, although we have seen here, we have not discussed uh, the if statement, means how to apply these logical operators and how to use id function in conditional operators or condition framing programs. So but this you'll have to have in your mind, this what are the logical operators and what is operator chaining and what is identity comparison. So hope you understood this video and hope you understood this concept, logical operators, operators chaining, and identity comparison. So if you understand the concept, then kindly share it with your friends and the people whom you want. And if you have not subscribed the channel, kindly subscribe it and drop a comment in the description box if you like this video. I'll be highly motivated. So we meet in the next video with some other concept. Till then, bye bye.